Section 6.5 is on a specific type of story problem. Some of these problems involve perimeter, value, interest, or mixture. To solve this type of problem, we're going to clearly state our variables, write a system of two equations, solve that system, and then make sure that we describe the result. Let's look at the first example here. It's a perimeter problem. The example says, for a golden rectangle, the length is equal to about 1.62 times the width. If an architect wants to design the base of a building to be a golden rectangle, what dimensions should the base be if the perimeter is 800 feet? Alright, so we're going to define our variables. Since we're talking about length and width, I'm going to use L and W. L for length, and W for width. Now we're going to write two equations. The first equation is going to come from the fact that the length is equal to 1.62 times the width. So L equals 1.62 W. The second equation is going to be about the fact that the perimeter is going to be 800 feet. I need to know what perimeter means to be able to figure this equation out. But I know that perimeter is 2 length plus 2 width for a rectangle. So 2L plus 2W equals 800. I have my two equations, and I want to solve this system. My technique can be either substitution or elimination, but because I know what L is equal to, it makes the most sense for us to use the substitution method. So when we solve, we're going to have 2 times 1.62 W in place of L plus 2W equals 800. 2 times 1.62 is 3.24 W plus 2W equals 800. Combine like terms, we're going to get 5.24 W equals 800, and then divide 800 by 5.24 to solve for W. We get that W is about 152.67. Now that we have W, we need to know what L is. Remember that L is 1.62 times W. So if we take 1.62 times 152.67, we get 247.33. Interpret the result. Let's make sure we go ahead and put our units back on here correctly. We're talking about feet as the dimensions right here. So we're going to say that the length is 247.33 feet and the width is 152.67 feet. Let's go on to the next one. This is a value type problem. Value type problems involve money. So if we're managing a performance or popular band, we've booked a 2,000 seat amphitheater where the band will perform for an expected sellout crowd. Market research indicates that buyers are willing to pay $75 for better seats and $50 for seats further from the stage. The goal is to take in $1.2 million in ticket sales. How many seats should we designate at each price? So the variables are the things that we're trying to find. In this case, it's going to be the amount of better seats and the amount of seats further from the stage. So let's just use X and Y. So I'm going to say X is going to be the number of better seats, and Y is going to be the number of further seats. I need to declare what my variables mean, especially when I use variables such as X and Y where it's not obvious what X might stand for. Let's check out the two equations. The first equation is going to be our total equation, the equation that deals with the number of seats. There are X seats that are better and Y seats that are further, and 20,000 seats total. So X plus Y has to equal 20,000. The second equation is the value equation. This has to do with the fact that it's $75 for one of the better seats and $50 for one of the seats that are further away. So $75 times X plus $50 times Y equals 1.2 million. Now I can't just write 1.2 here because this has a different unit than the number 75 and the number 50. These are in dollars. They're not in millions of dollars. If they were in millions of dollars, I could use 75 and 1.2. Because those are in dollars, I'm going to have to write out 1.2 million all the way out. So 1.2 million is 1, then 2, then 5 zeros. Now we want to solve the system. We can use either substitution or elimination. Since I used substitution in the last example, I'm going to go ahead and use elimination in this example. To use elimination, I need to have the same coefficient of x or y. I'm going to choose the smaller one. So I'm going to multiply the first equation by 50. That would give me 50y and 50y. I'm going to make it negative 50 so that I have one positive and one negative. So I'll have negative 50x minus 50y equals 50 times 20,000 is 1,000,000. The other equation won't change because it already had 50 as the coefficient of y. I'm going to add my two equations together. Negative 50 plus 75x is 25x. The y's eliminate, and I'm left with 200,000. And we're going to divide both sides by 25. That gives us x equals 8,000. Now that we know what x is equal to, we need to solve for y. So let's use the equation. We need either one, but I'm going to use the equation that has no coefficients, so it's easier to solve for. X is 8,000, so 8,000 plus y is equal to 20,000. If we subtract 8,000 from both sides, we'll get that y is 12,000. Now back up to the problem to interpret these values. 8,000 is x. X was the number of better seats, and 12,000 is y. Y is the number of further seats. So in order to achieve a sellout crowd, there should be 8,000 better seats and 12,000 seats further away. Let's look at the next problem. Type 3 is an interest problem. So in this problem, we're investing money. We want to balance the growth potential of the investment and the risk. Our goal is to have $50,000 to cover a child's expenses 10 years from now. And we're going to place some of that money in a conservative investment with a 5% return, and we're going to place twice as much money in a higher risk investment that's going to yield a 9% return. My ultimate goal is to make $1,950 in interest next year, so how much do we want to invest in each account? First step is to figure out what our variables need to be, and that last question helps us determine that. How much must you invest in each account? So each account is going to be the variables. So will X be the conservative account, and will let Y be the high-risk account? Now for the two equations. This $50,000 is the amount that we're going to have 10 years from now, so it's actually extra information since what we're talking about is next year for this particular problem. So we're not going to use this value. What we are going to use is the fact that we're going to invest twice as much money in the high-risk investment. So the amount in the high-risk investment Y needs to be 2 times the amount in the conservative account X. So that'll be my first equation. The second equation is going to be our interest equation. So I know that interest works by multiplying the interest rate times the amount in the account. So for the conservative account, I'm going to use 0.05, the interest rate, times X, plus 0.09 times Y. Add that up, and that should give us our total amount of interest, the 1,950. Those are my two equations. Because I know what y is equal to, it's equal to 2x. This is set up perfectly to use the substitution method. So I've got 0.05x plus 0.09 times 2x, replacing y with 2x, is equal to 1,950. Simplify, 0.05x plus 0.18x equals 1,950. And then add up your like terms right here. 0.05x plus 0.18x is 0.23x. And we'll divide both sides by 0.23. That'll give us an x value of approximately 8,478.26. Now our y value is going to be twice the x value. Y equals 2 times x. So if we multiply that by 2, we can see that our y value is going to be 16,956.52. Interpret the results. We want to invest $8,478.26 in the conservative account and $16,956.52 in the high risk account. If you want to check your answers, You could take these two values, the values for x and y, and plug them into both equations. We already know that y is equal to 2 times x, but we can check it by plugging the x and y value into the second equation and verifying that we do get $1,950 in interest. Let's check out the last problem. Example 4 is a mixture problem. In this case, it's a mixture of two solutions. One of them is a 10% alcohol solution, the other is a 30% alcohol solution. So these are the things we have on hand, and we're going to mix them to achieve a 22% alcohol solution. We want to know how much of each do we need to get 10 ounces of solution. So our variables, we'll use the letters x and y again, need to be the amounts of the solutions that we have. So we'll let x be the amount of the 10% solution, and we'll let y be the amount of the 30% solution. Now for the two equations. One of the equations is just the simple fact that if I pour x amount of 10% solution and y amount of 30% solution, I want to have a total of 10 ounces. So the first equation will be x plus y equals 10. The second equation is going to be our mixture equation. The x amount has a value of 0.10%, so 0.10x, plus the y amount has a mixture value of 30%, so 0.3y, equals, and 22% is the amount of solution over the totals I have, so 0.22 times 10, since 10 is the amount of total I will have. So if I rewrite this equation, since I can figure out what 0.22 times 10 is, this equation would be 0.1x plus 0.3y equals 2.2. Now we want to solve our system. We have the equation x plus y equals 10 and 0.1x plus 0.3y equals 2.2. To solve this system, I can multiply the top equation by negative 0.1 to make the x's eliminate. So let's do that for every term in the top equation. Negative 0.1x minus 0.1y equals negative 1. We're going to add that to the second equation. 0.1x plus 0.3y equals 2.2. So using the elimination method here. When you add these two equations up, the x's eliminate. The y's add to 0.2y equals 1.2. If you divide both sides by 0.2, you're going to get that y equals 6. I can use either of the equations to solve the x value. Since y is 6, let's go ahead and use the x plus y equals 10 equation to find out that x should be 4. And last, we'll interpret our results. X was the amount of 10% solution, y was the amount of 30% solution, and our units on these amounts right here need to be in ounces. So we need to mix 4 ounces of 10% solution with 6 ounces of 30% solution.